Properties of matter. In properties of matter, we have three main topics: elasticity, surface tension, and viscosity. So let's discuss elasticity first. But in elasticity, we have two main physical quantities we are using, that is stress and strain. Stress, the force divided by area. Here the force applied on a rod is F, and the cross sectional area of the rod is A. So force divided by area, we use it as stress. And strain, of course, when F force is applied on a string or a rod, the extension is E and the original length is L. So strain is E divided by L. Then Young's modulus. Young's modulus, this is actually the quantity of the material that is being used. So Young's modulus equals stress divided by strain. So F over A divided by E over L. So L goes up and E goes down. So this is the equation we are getting for Young's modulus, F over A L over E. Right. Energy per unit volume. So here the energy per unit volume is half into stress into strain. Right. Then when we are using rods or the strings combining together in series, in parallel here, of course the equivalent string that we can use, the equivalent strings Young's modulus, we can take it as, so here we have used two strings y1 plus y2, y1 and y2 Young's modulus, two different materials. So the combination will be y1 plus y2. So the equivalent Young's modulus has to be y1 plus y2. In the same manner, we can connect them in parallel, in series here. So then again, the combined one will be 1 over y, 1 over y1 plus y and y over 1 over y2. So in this method, you can find the equivalent Young's modulus here. Right. Then we have an important graph here. So this graph, in y-axis you can see extension and next we have force. So when the extension and force, they are proportional, we have up to P proportional limit, and then elastic limit. Up to elastic limit, the string, when we apply certain force, it will come back to the original position. After elastic point, yes, it won't come back to the original position, but certain amount of elasticity is there. After yield point, no, it won't come back, so we call it plastic behavior. Surface tension, here the force applied F and the length. So the surface tension T equals force divided by length, and a liquid drop is formed by using the surface tension here. So if the pressure inside is P1 and outside pressure P2, P1 pressure is greater than P2. So the pressure difference P1 minus P2 delta P equals 2T over R. Here R is the radius of the sphere. And the second diagram, we can see this is a soap bubble. So the radius of it R and the pressure P is greater than P naught, of course. Here there are two surfaces, so the pressure difference is a bit higher. So delta P equals 4T over R. Right. Capillary rise. So here capillary rise occurs because of the surface tension, and here you can see the radius of the meniscus is R, capital R, and the radius of the sphere is impel R. So there's a connection. If the pressure here is P naught and pressure inside P1, you can see P naught is greater than P1. So there's a delta P pressure difference equals 2T over R. Here R, it has to be the, yes, radius of the meniscus R. Right, first equation here. Then we can consider H rho G, the pressure difference, total height H rho G equals 2T over R. So we can subject H, capillary height, capillary rise, 2T over R rho G. So we are getting capillary rise height. And here you can see there's a connection with the radius of the meniscus and radius of the capillary tube. So let's find the connection. Here you can see R cos theta, capital R cos theta equals simple R. So capital R equals simple R divided by cos theta. So we can apply it here. Then h, capillary height, capillary rise, will be equal to 2t over, so we can replace capital R by R cos theta, 2t over R rho g. Here we get cos theta. Right. So you can remember this equation by two methods. Say now h rho g equals 2t over R, or then again h rho g equals 2t over simple R. Right. Surface energy. The energy of surface is surface tension into common surface area. So the total surface area is A. So here if we consider this is as a sphere, so we know the surface area will be 4 pi r square and surface tension T. So you can get 4 pi r square T is the total energy of this bubble here. Then moving into viscosity. Viscosity is liquid friction. So you know the equation F, liquid friction, F equals main equation eta capital A delta V over D. Here eta is the coefficient of viscosity, A is the surface area. Say now two surfaces are moving, two liquid surfaces are moving along, the area is the surface area of it, and delta V is a velocity difference between these two. Let's say this is V1 and V2, so velocity difference, and D is the separation between the surfaces. So first equation, liquid friction equals F equals eta A delta V over T. Moving to other equation, force on a small sphere. So this small sphere is moving downwards. Say for now it's downwards with a velocity of V, right? So the liquid friction applied on it is given by this equation Fv equals 6 pi eta AV. Here eta is the coefficient of viscosity, A is the radius of the sphere, and V is the velocity. Right. Then our next equation, terminal velocity. When the total force downwards, say here the total weight equal to the total force upwards. Here the forces we have upthrust and we have viscous force upwards. So mg equals viscous force plus upthrust. At this situation there's no resultant force, so there's no acceleration. Then the sphere will achieve a constant velocity, so we call it terminal velocity. Terminal velocity V equals 2 a square g sigma minus rho 9 eta. So here sigma minus rho, here sigma is the density of the sphere and rho is the density of liquid. Right, our last equation, Poisson's formula. Right, here it gives the volume flow rate of through a tube. So we have to consider this is as a constant surface, constant cross-sectional area tube. So R is constant, of course, and then total length will be L. So we get the equation volume flow rate, that means AV volume flow rate equals delta P, pressure difference, let's say P1 and P2, pressure difference across the tube, delta P pi R to the power 4 8 eta L. Right, these are all the equations. Alright, now it's your time to write the equations again. What you can do is you can keep the speed 1.5x 2x the playback speed and watch it again, or you can write along with it. Somehow manage to write the equations and try to by heart the equations and write them again. If you try again and again, you will remember the equations as well and theories as well.